Thank you for coming. We are going to talk about upgrading a big database, a large or very large database, I mean many terabytes, without little downtime. And when I said little downtime, I mean minutes, not hours. So first let me introduce myself. Me is Jaime Casanova. Jaime like in hat, but me. Okay. I'm a PostgreSQL contributor since 18 years ago. Founder of Ecuador's PUG. It's a little inactive, but it's there. I provide community support in Spanish in that mailing list and via a Telegram group, which that is the link. A board member of PostgreSQL Community Association of Canada, which keeps the trademarks of Postgres, and CEO of System Guards, which is a Latin-based PostgreSQL support company, providing especially Spanish support, but because we are inclusive, we can give English support, consulting, or training if required. Okay, so what are we going to talk? We are going to talk about first why to upgrade. We'll look an overview of the standard ways of upgrading and then a study case in which none of those standard ways solved the problem. So first, why to upgrade? Seems a curious question because it's obvious you need to upgrade, but if you are in a mission critical system, you don't want downtimes, you don't want problems, and probably you live by that rule. If ain't broke, doesn't fix it. Well, the problem is that it is actually broken because all software has bugs. And of course, most database vendors are not going to say you, oh, we found bugs. They are going to say you, we have a new feature, which is that we don't have this bug anymore. That's the reason why Postgres releases the minor releases. I don't like that word minor. It looks, people think about it like a minor update, minor in importance. It's important. So I prefer to call them security releases. And we'll probably will be fixing some security bugs, some vulnerabilities. Now, Postgres doesn't do minor or security releases for all versions, only supported versions, which always are the last 5. So currently 10 to 14. If you are using 9.6 and we have found a vulnerability, we don't know if 9.6 is exposed because we don't look at it. So if you are using older versions, you are exposed probably. And in a couple months, we are going to release 15, so 10 will lose support probably in November. So if you are using 10, start planning your upgrade. Okay, let's look an overview of the standard ways of upgrading. The first method, the oldest method, probably the safest one, is pgdump pg restore. Obviously, this is only useful if you have a small database or a large maintenance window. You cannot use this for a very large database. Why not? Because you must stop writing to the database before starting the dump. And that dump could take a lot of time. In a 20 terabytes database, which was almost documents, it took around 5 days to take a complete dump. And when that dump finished, obviously it was useless because there was a lot of writes during that time. Okay, I'm not going to stop there. upgrade, that's the only way, the other way, not the only, the other way to upgrade a database, which create the structure of the tables, create the schema of the database without any data. And then, because it knows there is no concurrency and it's completely safe, it copies the data at the operating system level. So it's a lot faster. How much faster? When on a 25 terabyte database, it took around 6 hours to copy the whole data set. Now, 6 hours is still a lot of time. We made a little patch to improve parallelism on the copy part, at least on the big tables, and it improved 20%. So it reduces the time to 4 hours, 40 minutes, which is still a lot. By the way, that patch is pending because it lacks Windows support, not good at that part, so it will be there for some time until I have time to finish it or someone wants to contribute that part. Okay. It could be, upgrade could be faster if you use the link option. What's the link option? Well, instead of copying the data, it will create an hard link, which is just, I would say, to simplify it, another name for the same file. I mean, the same space on disk. The bad thing there is that there is no rollback. Once you start the new cluster, the old cluster cannot be started again. How much fast could become that? On a 18 terabyte database, it took around 40 minutes. That's good. The bad thing, pgdump and pgupgrade make invalid all the standbys, all physical standbys. So you must reconstruct them from scratch. Maybe your business allows you to do that. But if you are using those standbys heavily, probably you cannot do that. Now, documentation of Postgres says you can reconstruct those standbys quickly with an rsync command, which basically will create the same hard links on the other side. It works. Always that all servers are shut down, and it will take the same time that the original pgupgrade took. So another 40 minutes for every server. So that will multiply things. Okay, that's a good option. But this is the better option. This is the new kid on the block, logical replication. And probably you understand what it does. What it does is you create the schema of the database without any data, and then create a publication on the origin, on the primary, and subscribe to that publication from the replica. It will create an initial copy of data. It will copy the whole data set. Okay, what's the good thing? The good thing is that you don't need to stop the service, not once. The bad thing, and it works between different versions, so all the standbys are still usable because you still have your original cluster, primary, standbys, and the new server, which is the new replica, logical replica. What's the bad thing? First, all replicated tables must have a primary key. That's a good thing to do anyway. But of course, the fact that the primary key must exist to replicate the data, even for the initial copy of the data, means this will take some time to complete. And it will take a long time, cause bloat on the primary, and consume space on primary. Okay, I will return to those points later. Remember that on paper, logical replication is the best thing you can do. And it's true for most cases. Now, let's start with the static case. By the way, let me see how much time. Okay, I'm very, very fine here. Okay, this is the static case. This is a financial system company, Latin-based, that process transactions from North, South America, and Europe. It works 24/7. All services must be online or can't be down for more than 4 minutes. That's a difficult restriction. They have 5 read-only replicas. So if they use PD upgrade, remember they have 18 terabytes. And so if they use PD upgrade, it took them 40 minutes to convert the primary. And then another 40 minutes for every replica, physical replica. That's a lot of time, a lot more than the 5 minutes we have. Okay, they were using 9.6. And that restriction is important for us. No server has more than 1 terabyte of free space. 1 terabyte is a lot. And it generates an average of 10 walls per second. So around 160 megabytes of wall per second. This is an average. It sometimes generates a lot more than that. Okay, so let's use that information. That's the cluster, primary, the 5 standbys. Okay. I will use PG logical instead of native logical replication. Why? Because 9.6 does not have native logical replication. It started on 11, if memory serves. It was developed by a company that then was called Second Quadrant, but since then it has been acquired by Enterprise DB, so now it's an EDB company. And PD Logical provides an API to implement logical replications on top of logical decoding, which was introduced on 9.4. So PD Logical implements logical replication since 9.4, basically. Till 14. Yeah, okay. And to use PD Logical, you will need to set that parameter, shared payload libraries, to PD Logical, and probably do a few other changes in configuration, so you will need a restart then. There. That's a few minutes of downtime. Now, if you have problems restarting your database because it's too big and it takes too much time to restart, you can set Maxwell size to a lower number, do a manual checkpoint, do the restart, and then restore the Maxwell size to its size, original size. That will help with that. Okay, after PD Logical has been installed on all servers, you need to create a replication set, which basically is a list of tables and sequences that will be replicated. It's the same thing that native logical replication calls a publication. And on the new server, you will create a subscription and the replica, which basically asks primary for the information in a replication set. in a publication. Okay, let's move to the next one. So that's the commands. Create extension logical, you create the node, and the replication set add all tables. I'm not adding the sequences here, but this is basically what it needs to do. Okay. The replication set will take not too much time and will not affect processes. Okay. Then, on the new replica, you are expecting to do this, which is basically creating a subscription. But sadly, you cannot do that. So we will not do anything of this. Why not? Well, we will return to this again. Remember, a replicated table must have a primary key, which means that the copy of the data that will be applied to the replica needs to maintain those indexes. That will take a long time, especially because it's a primary key and it needs to check uniqueness. The initial copy then will start on the primary a transaction because it will do a copy. That transaction will be kept open all that time. Suppose we have a one table with more than 5 terabytes, and yes, we had that table. And only the data of the table is 5 terabytes without indexes. On a 1 gigabit network, it took around 10 hours to copy the whole data of the table. What means that it took 10 hours? Well, that the transaction was open all that time, causing bloat on the primary for all that time. And it was consuming space on primary because the primary needs to retain the wall since the start of the process. Now, this is not like a physical replica in which you can wait a minute for the idea and then. This is not like physical replication in which you can archive the wall. Why not? Because the responsible to decoding the data and send it to the replica is the primary. So the information must be neat on primary. Okay, now.
I'm just curious, network bandwidth is usually something that they could upgrade. It was not possible to upgrade.
Not for them. Yes. Okay, let me first say that LATAM is a nice place to visit us in Ecuador. That's from Colombia. Colombia is a nice place too. But, now here's the but. Technology there is not like here. It was what we have and nothing more. Okay, so, but yes, if you have a better network available, please use it for that, especially. Now, on those 10 hours, only moving that 5 terabyte, which is not a complete database size, consume around 5 terabytes on the primary, just retaining WAL. And if you remember, we don't have 5 terabytes free of space on those servers, just less than 1 terabyte. So the initial copy is a problem. We need to solve this first. What are we going to do? Well, we actually have all the data already on another server, the physical standbys. So what we are going to do is take a physical standby and transforming it into a logical replica. After that, of course, it will be on the same version, 9.6. After that, we are going to pre-upgrade it. And finally, we will continue the logical replication from the exact point it stopped. So no data is lost in the process. It's lost in the process. Okay? How do we transform a standby into a logical replica? Well, pglogical provides us this command, pglogical create subscriber, which does exactly that. And with those commands, basically, you can make it work. If you have several databases, this is a list separated by commas. I'm using the default replication set, which is one of the replication sets pglogical provides by default. Okay. Pglogical create subscriber does nothing special. It just does the same thing Postgres can do by itself, but in the correct order. So please do that, or read the code, and if you want to do manually, repeat the steps in the same order. Now, after that command finishes, we have a 9.6 logical replica. But we need it in a better version than 9.6. So the first thing we need to do is stop replication. So we disable the subscription. So primary will keep retaining val, but will not send information to the replica. And after we have disabled the subscription, we copy that catalog, PG replication origin status. Every row of that catalog keeps information about what have received from the origin and on which position in val locally we have applied that. What we actually need is the external ID, which is the, if I remember correctly, no, I don't remember correctly. External ID and remove the LSN. The external ID is the slot names, I think, on the primary. And the removed LSN, which is the exact position on val from the primary that we have received, the last one. It will have that information for as many rows there as databases that we have replicating. Okay. Put it in a file. You can put it actually in the real case. I put it in a table on the primary, so I can script it all. And after we have done that, we can PG upgrade the standby. Okay, I put a lot of spaces and tabs there, but it's one line basically. Everyone here recognizes the command, right? And knows how it works. The lowercase is the old cluster, the uppercase, the new cluster, port, binary path, and data directory. The link option is the one that creates the hard links. And we first check that both clusters are compatible. And after we check that it will work, we can ignore that we can leave that option out, so we can actually upgrade it. Now, we are still not doing this. We are doing this without stopping services. Remember, the only downtime here up to now is when we installed PGLogical. Primary is working fine. Only this logical replica is being stopped, and it's a different server, so it doesn't matter. Okay. After upgrading, then you need to inform the new logical replica, which now it's in a better version. Which version we were here? 13. You can do this with 14, of course. We need to inform that it was replicating from an origin and exactly at which point we stopped. We do that with these two functions, PG replication origin create and PG replication origin advance. By the way, why we need to do this? Because PG replication origin status is a catalog, and catalogs won't survive to PG upgrade. Well, the changes we have done to those catalogs won't survive to PG upgrade. And basically, that's the reason why you need to do this with PG logical. And while probably could be done with native logical replication, it would be more complicated than this. Okay, so, and of course that's fake LSN. Take the one from the file. Okay. After you have filled that catalog, then you can re-enable the subscription. So what do you have there? Now you have a Postgres 13 logical replica of the primary on 9.6 starting on the same exact point. You have lost no information in the process. Currently, you have only downtime for the initial restart. Okay, at this point, you can do whatever you need to do on the logical replica. For example, they needed to change some integer fields for begin fields. Do that on the logical replica before doing anything else. Create the indexes you need to create. You haven't added sequences to the replication set. You can now, just before the switchover, set val them. This procedure has been tested with PG logical. There could be possible to do the same with native logical replication, but the exact steps may differ. Bruce, please say EDV that PG logical must exist for some time yet. And I mean PG logical 2.x series. Yeah. Now, what are you going to do after this? Because currently we have just one server with, which is a logical replica of 13. Well, just start moving the load of one of the standbys to that logical replica. So the load is still on another server, is still running. Take down this standby and recreate it from scratch on the new replica as a standby of the 13. In this case, that took around 15 days to recreate all the standbys. But it doesn't matter because the load is the same and there is exactly the same amount of servers working. Yes, we used a time in which they have added 2 additional servers to cope with the load. So after that time, instead of returning those servers, they keep it for a few extra time for doing this. And at the end, when everything is on 13 except the old primary, And yes, they were working 15 days, even a little more than that, writing on 96, replicating to 13, and then replicating to the standbys on 13. And they were working without problems. The delay was almost zero, not noticeable for them. The last downtime will happen when you stop writing there and move the load to the other server. You can do that, just with a maintenance window. Of course, what about the load on this? Because in some point you need to stop making queries here, right? Is that also a downtime? Not necessarily. You can use PG Bouncer, for example, to move the load gradually. And you are not going to notice any loss, any downtime, maybe a glitch only. So there, we did this with around, summing up, it was around 10 minutes of downtime, distributed in a few maintenance windows. But of course, it took a lot of time to plan. We did the script for this and test all the scripts and make a lot of things during 3 months before doing this. But it works very good, and we have a lot of time, and I have finishes everything I have. So please, if you have any questions, now is your turn.